Today we're going to be going over LeetCode number 1, which is twosome. So this problem can be solved in two different approaches. One is least efficient with an O of n squared time complexity and involves a double for loop, an inner and outer for loop. And then there is a more efficient solution, which I will also show you, which is a linear O of n time complexity. It involves using maps. So in this problem, we are given an array of integer nums and an integer target. So what we want to do is return the indices of the two numbers such that they add up to the target. So we have an example down here which will make this much more clear. We have a nums array which is comprised of four numbers, 2, 7, 11, and 15. And then we have a target of 9. We know that 2 plus 7 is equal to 9, so we do not want to return the 2 and 7, but we want to return the corresponding indices, which is 0 and 1. So we return that as our output. Two things to note with this problem is that we are guaranteed to have only one solution and only one solution. So this means that we do not have to worry about the case where there are no solutions. And also, once we reach that first solution, since it's the only one, we can just return that output and not have to go through the rest of the loop. So we will go to Excalidraw and I'll show you the two algorithms. I have an example drawn out for you guys. We have this array again with 2, 7, 11, and 15, but I've changed our target to be 18 in this case. And the first way of solving this problem, which might come to your mind, would be to look at every combination of numbers and see which combination will be equal to 18, and then return the indices based on that. So this is a pretty obvious solution, but is also the least efficient, and I will show you guys why. So in order to do this, what we're going to have to do is we're going to have to start with each number and then compare it with every other number in the array. Right, so what we would do first is start off with the 2. So we are looking at the 2, and what we want to see if any number inside the array summed with 2 is going to be equal to 18. Right, so we start with the 2, and then we look at every other number inside the array. Right, so at this point, what we will do is we have the 2, so we're going to see if 2 plus 7 is equal to 18, but no, it is equal to 9. So we're going to move on to the next number. Then we have 2 plus 11, which is going to be equal to 13. It's not equal to our target either. And 2 plus 15 instead is equal to 17. So we have not reached our target. So at this point, what we're going to do is we're going to go on to another iteration of a for loop. And we're going to start looking from the 7 this time. So we have our 7, and that's going to be the number we're comparing with every other number in our array. And what we are going to do is compare it with every number after it in the array. We don't have to compare it to the 2 again because that comparison of 2 of 7, as we can see, was already done previously. So we can shorten this code a little bit to just look at the numbers after the current one in the array. So we are on the next iteration of our for loop, and within it, we're going to have to look at every other number within the array. Hence, there's going to be an inner for loop to check the other numbers. So again, we are going to check this sum. We're going to see if 7 plus 11 is equal to 18, and it is, in fact. So what we will do is we're going to return the indices 0 of 1, which correspond to the 2 and 7 as our result. So we're going to write this code in Python quickly just to show you how that would look. And so what we would say basically is if we're given our input of numbers and target, right, what we would do is we'd say for I in range of from 0, we are going to go up to the length of numbers, and we're going to go on with increments of 1. And then inside, we're going to have an inner for loop where we say for j in range of I plus 1, we're going to go to the length of numbers and in increments of 1. And what we're going to say is if numbers of I plus numbers of j is equal to our target, which in our example was 18, then what we do is we return an array which will have the two indices, so I and j. And this would basically be the code for this less efficient solution, which will have quadratic time complexity. And the reason why it's quadratic is because when going through this, we see that we have an outer for loop here, and another second for loop, an inner for loop here, where right when we go into every element I and then every element j in order to do this comparison. And even if we are not looking through the previous numbers in the array in the inner for loop, because we're starting from I plus 1, this will still end up being an O of n squared time complexity. Right? So what we want to do is try to make this a more efficient solution. Okay, so now what I'm going to show you guys is how to improve the solution from a quadratic time complexity to a linear time complexity using maps. Because as we can see in our previous solution, even if with this specific example, we do not go through every combination of numbers and we stopped once we reach 7 plus 11, our worst case, big O time complexity will still be n squared because there will be some cases where we'll have to do every comparison. Say if, for example, our target was 26, we'd need the 11 plus 15, so we'd do much more comparisons. So what we will do instead is use a map, and a map is a data structure which allows us to store a key along with a corresponding value. So we're going to have this map, right, and we're going to have a key value pair, right? And for example, what we would have here, like when going through the 2, would be a 2 as our value and our 1 as the index, right? So this is what we're going to do, and it will allow us to eventually just go through the array one time, and based on what is already stored in the array, we will be able to return the indices by only going through the array once. So it will become a linear time solution. So I can just go and erase this here so I can show you how this algorithm will work instead. So basically what we're going to do is we're going to start off by looking at the 2. We're going through the array only once and we're starting off looking at the 2, right? So we have our map down here, which initially will be empty. So we do not have this 2 and we do not have this 1, right? We have an empty map, and we go and look to see if there's anything in our map which has a key number which is equal to 16. The reason why we're looking at 16 is because remember our target was 18. Right, so we're going to do 18 minus 2 is 16, and we're going to go and check to see if we have a 16 in our map. We do not. So what we're going to do is we're going to just go and put our 2 inside the map, right, along with its corresponding index of 1. We're done with the 2, and we're going to move on to the next element in our array. We have a 7. So we're going to check if we have an 11 in our map, because 18 minus 7 is equal to 11. We do not have an 11 in our map, so what we're going to do is we're going to go and put the 7 in our map, along with its corresponding index, which is 1 actually. I have a mistake here. This should be 0 instead, because in this map start labeled from 0 as index, right? Okay. Then we're going to go on to our 11 here, and we're going to check if we have 18 minus 7, 18 minus 11 in our map, right? So we know 18 minus 11 is equal to 7, so we're going to go and check for a 7 this time in our map. And when looking in the map, we're going to see we do have a 7. So we know we have found our pair, and we can return the corresponding value of the 7, which we have here as 1, indicating its index, right? And we will return that along with the index of the current number we are looking at. So that's how the algorithm will work. As we can see, in this case, we're only going through the array once. We do not have a double for loop. Right, and this because we are only going through the array once here. What this means is that our time complexity is going to be O of n linear because we are only going through the array once with a singular for loop. So this is a great improvement compared to the first algorithm I showed you guys. Okay, so we're back here in LeetCode and we're ready to write up our code and submit it. So remember, the first thing we wanted to do is we wanted to create a map in order to store the elements we have visited and to keep them in memory. So we're going to create our map, which initially will be an empty map. And I'm just going to write here in code where our key value pair will be. So we know that our key is going to be the number and the value is going to be the index, right? So then we're going to go through our array, and we have for I in range from 0, because arrays start from 0, length of nums, and an increment of 1. So we're going to go to the end of the nums array and go in increments of 1. And what we're going to do each time is calculate our difference, which is going to be our target minus the current number we are looking at. So remember, say if our target is equal to 7 and current number is equal to 13, then our difference would be equal to 13 minus 7, which is 6, right? And what we're going to do is we're going to check to see if this difference is in our map. So if difference is in map, we're going to return an array which will have the corresponding value in the map for the difference, right? Because we want the index along with the index of the current number we are looking at, right? And in the other case where we do not find the element in our map, so if the difference is not in our map, we just want to add the current element to our map. So we're just going to set map nums of I equal to I, right? So this sets new key value pair, and this is going to instead return the value along with current index, right? So now we can submit it and make sure it runs. So it runs, and let's see if it submits. And yep, as we can see, it works and it's pretty efficient. So thank you very much for watching this video, and I hope it was helpful for you.